Lesson 22 is on multiplying and dividing fractions. And multiplying and dividing fractions is actually a lot easier than adding and subtracting fractions, because in multiplying and dividing fractions you can just multiply straight across. Multiply the numerators and multiply the denominators. You don't have to find a common denominator. Number 1, Mariah ran 14 miles in 1 week. At that rate, how many miles would she run in 5 days? Well, 14 miles divided by 1 week is 7 days would give us how many miles she runs each day. And then if she's going to run 5 days, days will cancel out. So 14 divided by 7 is 2, and then 2 times 5 is 10. The triathlete swam 2 miles in 56 minutes. Then he rode his bicycle 100 miles in 5 hours. Finally, he ran 20 miles in 160 minutes. How many minutes did it take him to complete the course? So everything in terms of time is given in minutes except for 5 hours. So we need to convert 5 hours. And we know that there is 1 hour in 60 minutes. So we know that we multiply 5 times 60. Well, 5 times 6 is 30. And then 60 would make it that. Hours cancel out, so that's 5 hours is 300 minutes. So how long did it take him to complete the course? We have 56 minutes, 300 minutes, and 160 minutes. So 56, 356, 456, and then 516. Let's double check that. 56, 300, 160. Yep. So 516 minutes it takes him. And then, during which portion of the race did he have the greatest average speed? Well, speed is calculated by taking the distance divided by the time. So for the swimming, it was 2 miles divided by 56 minutes. And 2 divided by 56. Again, since this isn't the purpose of it, I'll let you use a calculator. That comes out to be 0.0357. And then for biking, he did 100 miles in 300 minutes. So 100 divided by 300 is 1/3, so 0.333, repeating. These are miles per minute. Miles per minute. And then running is 20 miles divided by 160 minutes. 20 divided by 160 is 0.125 miles per minute. So comparing these numbers, we have the fastest speed is 0.333 miles per minute, or biking. Number 3 says to expand. This uses the distributive property. So distributive property says that you take the 3 and you distribute it or multiply it through So you have 3 times x, keep the symbol that's in between the numbers, plus 3 times 7. 3 times x is just 3x. 3 times 7 is 21. Number 4 says factor, which is the opposite of the distributive property. So it's like you're starting with this, and you want to get to this. So we need to figure out what factor 5 and 35 have in common that we can use. So since there's only 5 here, and 5 is a prime number, hopefully 5 goes into 35. It does. So I have 5 times x plus 35 divided by 5 is 7. So 5 times 7. And then I have this 5 and this 5. Kind of like where I had this 3 and this 3. And those 3's came from the 3 out front. So this 5 is going to come out front. And then in between, what's left is what's left after I take those 5 out. So I have x plus 7. Number 5 deals with the order of operations. And when you have things in fraction form like this, it's as if there's parentheses on the top and the bottom. So you do those ones separately and you do them first. So parentheses on top, 6 plus 4 is 10. 7 minus 2 is 5. And then I can do the division of 10 divided by 5 is 2. Again, we have order of operations. Please excuse my dear Aunt Sally. I don't have parentheses. I don't have exponents. But I do have multiplication and division, which I do from left to right. So 5 times 4 is 20. Keep everything else except the multiplication the same. So 2 divided by 1 is 2. And now that I don't have any more multiplication and division, I do addition and subtraction from left to right. So 6 plus 20 is 26, minus 3 is 23, plus 2 is 25. Compare. 6 minus 19 is negative 13, but on this side, it's in absolute value symbols. So the absolute value of negative 13 is positive 13. And then 6 minus 19 on this side is negative 13, and there are no absolute value symbols. So we're comparing positive 13 and negative 13. And positive 13 is bigger. Number 8 actually deals with lesson 22. And like I said, if we are finding or multiplying, it's way easier than adding or subtracting fractions. All we do is multiply straight across. So 3 times 1 is 3. 4 times 3 is 12. So 3/12 would be the answer, but now I need to reduce. And both 3 and 12 I can divide by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So that's 1/4. They also showed you in the example in the packet, and you can look back at this, that when things are factors or the same diagonally, you can cross them out or cancel them out. So 3 divided by 3, and then we would have just had 4 times 1 and 1 times 1 on top and given us 1/4 that way as well. What number is 1/3 of 3/5? Remember that the word of means multiply. So basically they're asking what is 1/3 times 3/5. And we'll use the trick that I was just talking about. So we have 3 on top and 3 on the bottom. And I can divide both of those by 3. So 3 divided by 3 is 1. 3 divided by 3 is 1. So now I just have 1 times 1 on top is 1. 1 times 5 on the bottom is 5. Now you would have gotten the same thing if you had gone through and done 1 times 3 on top and 3 times 5 on the bottom. You would have had 3 over 15, and then both of those have a factor of 3 that you can divide out, and you end up with 1/5 either way. So choose which method makes the most sense to you. You're either simplifying ahead of time or simplifying afterwards. The reciprocal of a fraction is the fraction flipped over. So if I have 1/7, I switch the numerator and the denominator. So the reciprocal of 1/7 would be 7 over 1, and we would just call that 7. Anything over 1 is just the top number. What is the multiplicative inverse of 2/3? Multiplicative inverse is the exact same thing as the reciprocal. They mean the same thing. You find them the same way. So if I'm going to find the multiplicative inverse of 2/3, I flip the 2 and the 3. So it's 3/2. And typically when you give a multiplicative inverse, you would give it in an improper fraction like that. But you could also say that that is 1 and 1/2. Find x squared plus 2yz. When x is 4, y is 5, and z is 7. So 4 squared plus 2 times 5 times 7. 4 squared is 16, 2 times 5 is 10, times 7 is 70. 16 and 70 is 86. Now in number 13, when we divide fractions, the only thing that's a little bit tricky is when you divide fractions, it's the same thing as multiplying by the reciprocal. So when you see the division symbol, you take everything to the right of the division symbol, and you're going to do something new. So we're going to rewrite it. 3/4 stays the same because it's to the left of the division symbol. The division symbol turns into a multiplication, and then we multiply by the reciprocal. Well, the reciprocal of 1/3 is flipped over, so it would be 3 over 1. So 3/4 divided by 1/3 is the same thing as 3/4 times 3, or 3 over 1. So again, 3 times 3, when I'm multiplying, I just multiply straight across. 4 times 1, and then that would be 4 goes into 9 twice, and I have 1/4 left over. And the perimeter and area of this triangle. Perimeter comes from adding up all the sides. 12 plus 13 is 25, plus 5 is 30. And then the area of a right triangle is 1/2 the base, which is 12, times the height, which is 5. Half of 12 is 6. 6 times 5 is 30. And then for area, it's the units squared. For perimeter, it's just the units. Classify this triangle by angles and sides and state the measure of each angle. So by angles, every angle is less than 90 degrees, which means that it's an acute triangle. By sides, these tick marks tell us that all 3 sides are the same length. That means it is an equilateral triangle. Lateral means side, equa means equal, obviously. And then state the measure of each angle. If sides are equal, then angles are equal. Since all 3 sides are equal, all 3 angles are equal. And within a triangle, all of the angles add up to 180 degrees. So if there's 3 equal angles adding up to 180 degrees, then I could find one of them by dividing 180 by 3. So 180 divided by 3 is 60 degrees. And then I can check if I have 60 plus 60 plus 60, when I add up all the angles in a triangle, it should add up to 180. 60 plus 60 plus 60 is 180. So that works. Find the area of a square with a side length of 17. Now, at first glance, it might seem like they didn't give you enough information because they only gave you one side. But if it's a square, all the sides are the same. So this is 17 inches, this is 17 inches, all of them are 17 inches. So to find the area, I multiplied the length, which is 17, times the width, which is 17. So I can do 17 times 10, and then 17 times 7. 17 times 10 is 170. And then 17 times 7 would be 70 and 49, 119. Whoops, 70. And then that would be 289. And it's area, so it's inches squared. Let's double check that. 17 squared, 289. Yep. Number 17 asks, is this figure a polygon? Why or why not? Polygon has to be a closed figure, which this one is. It needs to be two-dimensional, which this one is. And it also needs to have straight sides. So, no, because it has a curved side. Polygons need to have straight sides. Can an obtuse triangle be regular? Explain why or why not. The word regular in terms of polygons means all sides and angles are equal. Now, an obtuse triangle means one angle is greater than 90 degrees. So if you picture an obtuse triangle would look something like this. Any obtuse triangle that you would draw, there can only be one obtuse angle. So there would be no way for the other two angles to match the measure of this angle, because if all of the angles in a triangle add up to 180, and this angle right here is more than 90 already, you can't have three of them add up to 180 because two 90s add up to 180. So the answer is no. Because an obtuse triangle can only have one obtuse angle. Number 19 says, choose the appropriate symbol to complete this statement. So down below, it's important to understand what the symbols mean. So we have this symbol here means congruent. And what congruent means is that the shapes are exactly the same. In B, the squiggly line means similar. And basically what similar means is that the shape might be bigger or smaller, but it still looks the same. And all angles are equal. In C and D, they aren't actually symbols that you would use along with shapes. Equals and less than are symbols that you would use if you were talking about numbers. So this is equal, not used for shapes. And then this is less than. And it's also not used for shapes. So the only two that make sense at all for this problem are A and B. So now we have to look at the two triangles, and are they exactly the same, or do they look the same, maybe one's bigger or smaller than the other? So one thing that tells us that they aren't bigger or smaller than the other is that these lines mean that each side is equal in length to the other ones that have that same mark. Since all of the sides have the same mark, that means that all of the sides are the same length. So these shapes are exactly the same. They are congruent. So the symbol that would go in here is the one for A. WYX and XYZ form a linear pair. So we have W, Y, X, and then X, Y, Z. Linear pair means it's one line there. I'm going to try and redraw this so it doesn't look so off. So we have W, Y, and Z, and then X is up here. So WYX and XYZ form a linear pair. The measure of XYZ right here is 60 degrees. And they want to know how big is this. Well, if this whole thing is a straight line, this adds up to 180 degrees. And this takes up 60 of it. So how much is left for this angle? 180 minus 60 is 120. Name this figure. Well, something that starts with a dot and goes to an arrow is called a ray. And a ray is something that you have to name in the order. So if you look above the A and B, you see that there's an arrow pointing. That arrow has to go the same way as what it does in the figure. Now, in the figure, it points to the left, and in the two options, it points to the right. That's not what I mean. What I mean is that in the figure, it goes from F to E. So the end without an arrow has to be on F, and the end with an arrow has to be on E. So in A, it's the end without an arrow is on E, and the end with an arrow is on F. So that one doesn't work. In B, the end without an arrow is on F, and the end with an arrow is on E. So it's B. A freeway passes under a street. If we think of the freeway and the street as lines, we would say the lines are intersecting means that they actually run into each other. But since they aren't in the same plane, one's above the other, this is something called skew. Parallel would mean that they're in the same plane and they don't intersect. (23) Round 403 million to 500,000 to the nearest million. Well, the millions place is right here on the 3, so everything after that line is going to turn into a 0. So we look, and after the line is a 5. That means that this 3 is going to round up to a 4. So we will have 404, and then everything else after that is a 0. Estimate the product. Well, if I was going to round 17.89, I would call it 18. And if I was going to round 9 and 7/8, 7/8 is more than half, so I would call that 10. So 18 times 10 is 180. Name a set of numbers that includes 1 but not 0. Well, the set of numbers that does not include 0 is counting numbers. You start at 1 for a counting number. Number 26 says the square root of 64. So that's asking what number, when you multiply it by itself 3 times, cubed root, 3 times gives you 64. Since it's even, we could start and try 2. 2 times 2 is 4, times 2 is 8. Well, 2 is too small, so let's try 4. 4 times 4 is 16, times 4 is, 16 and 16 is 32, and 16 is 48, and 16 is 64. So 4 cubed equals 64, so the cubed root of 64 is 4. In 27, we have 1 1/3 plus 1 1/6. So what I typically do is I add the whole numbers, and then I just deal with the fractions. And I know that 1/3 can go into 1/6, so I'm going to write 1/3 in terms of 1/6, or in terms of 6. So to go from 3 to 6, I multiply by 2. So whatever I do to the bottom, I do to the top. So 1/3 is 2/6. So then I have 1/3, I'm going to write as 2/6, and then plus 1/6. 2/6 plus 1/6 is 3/6. So I have 2 and 3/6, but we would say 3/6 is 1/2. Because I can take 3 and 6 and divide them both by 3. Write 7/8 as a decimal number. The way that we do that is we divide 7 by 8. I'm going to do that over here in the space. 7 divided by 8. Well, 8 can't go into 7, so what I do is I turn it into, instead of 7, 7.0. And then I bring the decimal up above. So 8 goes into 70 now is the question. 8 goes into 70 8 times, because 8 times 8 is 64. 70 minus 64 is 6. Since I still have a remainder, I'm going to call it 7.00 because that still equals 7. I haven't changed it. I'm going to bring that 0 down. 8 goes into 60 7 times. 7 times 8 is 56. 60 minus 56 is 4. Since I still have a remainder, I'm going to add another 0 because 7.000 is still 7. Bring that 0 down. 8 goes into 40 5 times, and 5 times 8 is 40. And now that I have a remainder of 0, I know I'm done. So 7/8 as a decimal is 0.875. What is 3/5 of 35? Well, 3/5 of means 3/5 times 35. So I can do 35 times 3 divided by 5, but I don't know offhand what 35 times 3 is, so I'd rather divide first. So 35 divided by 5 is 7, and 7 times 3 is 21. So 35 divided by 5 times 3. That's how we got that one. And the last one, a home in the mountains is going to be built with a steep roof to keep heavy snow from accumulating on the roof. If the roof is at a 70-degree angle as shown, what is the angle at the peak? Well, remember that all the angles in a triangle add up to 180. So we know two of them. So we can take those two off of the 180. So 180 minus 70 is 110, minus 70 is 40. So the leftover angle must be 40 degrees.